solve another Leetcode problem 2086, minimum number of food buckets to feed the hamster. This problem is a very typical greedy problem. Normally greedy problems have no patterns, but this problem is really famous. So we should try to understand why we're gonna solve it by using this kind of greedy. So the hamsters will be in a line. So for this string hamster, so the H represents the hamster, and the dot represents the empty spot, which we can put a donut. So we are going to return the minimum number of food buckets you should place at empty indices to feed all the hamsters. So we need to meet the condition to feed all the hamsters, otherwise we're going to return a -1. So this means it is not impossible. It is not possible, right? So let's just check this example. We can put a donut here and put a donut here. So this is okay because so this means at least we need 2. We cannot put 1 because if we just put 1, so what about another hamster? If we put here, this one is not okay, so we have to put another one. So this is a 2. But let's just check this one. For this one, we had better put it in the middle instead of at the left side. So from here, there's some greedy idea. So for example, if we put a donut here, so this one is okay. So what about that one? We have to put another one, maybe here, but at least we need 2. But what about we just put it in the middle? If we put it in the middle, we meet the 2 conditions. This one is okay, this one is okay, and the final result is only 1. But what is the idea? So the idea is for a hamster, if this is a hamster, let me use it this way. If this is a hamster, and then we have 2 positions to put a donut, whether we will put it at the left side or the right side. So this is the greedy idea, because if there are 2 dots, we had better put it at the right side, because if we put it at the left side, what about there is another hamster here? We are not sure. But what if we just put it at the right side? We put it here. So this means this one can meet the left side condition and the right side condition, and in this way, we can put the minimum donut. If we have this kind of idea, normally we can start coding to solve the problem. But there are some other cases we have to be careful with that. So for example, the hamster can be in a line. So there are 3 hamsters in a row. So for this one we can put here, but for the right one we can put here, this one. But what about this one in the middle? How should we solve that? It means while we are checking this hamster, if we cannot put a hamster at the left and we cannot put it at the right, so we're gonna return a -1. This means it is impossible. Now let's go back to the code to finish the coding. We're gonna need to check the length of the hamster, and we also need to have the I and result. I is the index from 0 and result is also 0. Now we can start to check the hamsters one by one. So if hamsters I, if this is a hamster, if it equals to 8, then it is a hamster. So the greedy solution is that we have to check it from the right side first, and then go back to the left side. If the right side is not possible, and then we're gonna check the left side. If both sides are not possible, we're gonna return a -1. So we have to check the right side. So if I plus 1, this is the right side, should be less than n, and hamsters I plus 1 equal to a dot empty. If it is equal to a dot, it means we can put a donut there, and we have to put it there. So we will put it. So if we put it, so the I should be updated to which position. So let's check it. So for this example, if we put a donut here, and what is the next position? So for if we put a right here, this means for the next position, this I is here. For the next position, this I will be here at this position. Why? Because if we put a donut here, even this is a hamster, we've already met the conditions. Because this is a donut. So this means for this I, it's gonna be updated to this position, it should be okay, and then we're gonna check the hamster. But how can we jump to the this position? It means from 1 to 3, 3 positions. So this means from here, our I will be updated to 2 positions, because after the while loop, we're still gonna update it to 1 position. Yeah, so this gonna be the right side. And if we're gonna check the left side, so this means I minus 1, should be more than or equal to 0, and hamsters, we're gonna check if there is, so I minus 1 equal to a dot. Yeah, if at the left side there's a hamster, so what are we gonna do? Now I think we can use another example, maybe this example. Yeah, if we put a donut here for this one, and it is at the left side, and this is a dot, and this is our I position of the I, the index I. At the left side, it has a donut. So what about the next step? Next step, definitely we're gonna check this hamster. We cannot jump to the third one because this one has not been checked yet. So we're gonna I should be updated to 1 position. So we only need this one. I need 2 plus 1. Yeah, and then it goes to here. At the left side, there's no empty slot. At the right side, there's no empty space. So it means we're gonna return a minus 1. So up to here, we just need to update the result, and also for the right side, we're gonna update the result to the plus 1, and also for the left side. But we don't need to update the I because we only need 1 position. And for the third condition is that if we cannot put both sides, we're gonna return a minus 1. So finally, we just need to return the result. Now let me just check it if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast, and the time complexity is O(n), and n is 10 to the power of 5. Thank you for watching. See you next time.